Hi, and welcome to the first of our H4 videos that explain how H4 works, how best to use it, starting with why you need it. So we're going to look at the fundamentals of multitasking. But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. Now, there is a fair amount of theory in this compared with other videos in the H4 and H4 plugins series. But it's necessary because the general concepts behind multitasking are important to understand, because not understanding them is where the problems start. Now, once we've got past a few of the definitions, then you'll see why H4 is going to help you out and why you don't need to know as much about multitasking as you would need to if H4 didn't exist. Much of what follows applies generally to any kind of multitasking, not just H4 and ESP 8266. But let's get some simple terminology out of the way. There's your bog standard Arduino IDE Blinky code. That piece in the middle, which is the loop, we're going to call from now on the main loop. You'll understand why later. Sometimes we're going to even call it the main loop context. All microprocessors can allow what's called an interrupt. And an interrupt in its simplest form is that your code is forced by the hardware to stop running. Some other code runs, often code over which you have no control, you don't even know exists. And when that code is finished, your program code resumes exactly where it was when it went. Now, as I say, you have no control over when that happens. It can happen at any point in your code, halfway between two parts of an instruction even. And when code that does that runs, we say that that's running in the interrupt context. So basically we have two contexts, the main loop context and the interrupt context. Now then, what we're going to look at is some of the things that cause that to happen. One of them is a timer function, and that's what H4 deals with, and we'll go into more detail about timers. But just before we finish on context, I want you to think of this. If, in the terms of what we've seen so far, the main context is like a major superhighway with lots of traffic and lots of busy things going on it, then the interrupt context is like that. Now, it doesn't matter why or how. All you need to do is trust me. But because of that, code that runs in the interrupt context cannot perform long tasks because it's stopping your code running, isn't it? It cannot perform complex tasks because it doesn't have access to some of the same resources that the main loop context does. And it's deadly when dealing with shared data. I'm going to show you briefly what I mean in the next slide, but take it from me that running in the interrupt context is not a good idea, should never be done if you can avoid it, and is very, very, very complicated and difficult to get right. So moving on. Imagine that your code is examining the elements of an array of length 10. You've been through 0, 1, 2, 3, 4, 5, 6, 7. You are just about to access element 8 when, without any warning and totally beyond your control and totally invisible to you, an interrupt occurs, and the code in the interrupt happens to delete element 8 of that array that is shared between the main loop context and the interrupt context. What do you think is going to happen when your code continues? Because it's just about to pick up element 8, and element 8 has been deleted. It's not there anymore. Using the same highway metaphor, that's what's going to happen. So, and that is just a tip of an iceberg in dealing with interrupts. So let's have a quick recap. They're notoriously complex. They require specialist hardware knowledge because the interrupt management and handling is different on different micro controllers. It requires specialist programming skills and techniques. It can cause subtle and difficult to find problems when misused. Google timing error if you don't believe me. It's got the potential to crash your entire system at the slightest mistake you make. You know, it's not just going to print out the wrong result or put things backwards. Your machine's going to go into a boot loop, and unless you're an expert, you're not going to be able to know why. You need to understand how to manage shared data, race conditions, deadlocks. What do they feel? I've never heard of them. Exactly. You cannot deal with interrupts correctly unless you have heard of them and understand what they all mean, what the implications are. So the bottom line is, so that we can move on, it is absolutely not for beginners. Having said that, the problem is that it's the fundamental basis for being able to do multitasking. So really we need a way to do the same kind of thing, but in a much more simplified fashion. So, timers to the rescue. Now, in that little graphic on the left, you've got some of the things that can cause an interrupt. A timer, some voice command coming in off the network, a GPIO pin toggling on and off, maybe a PIR sensor just went hot and fired on GPIO 3. Web interface, other computers talking to you. There's a multiple sources of things that can cause an interrupt to occur that your code has to deal with somehow. H4 deals with timers. H4 plugins is the library that deals with all of those complex, rich and wonderful interrupts, right? Timers are dealt with by H4 and that's all it does. So it makes life a lot easier. And the reason we need that as the basis of dealing with any kind of interrupt is because real world events happen asynchronously. What does that word mean? It means without any kind of consideration as to the order of time. In layman's terms, whenever they want to. You have no control over them, basically, is what it means in programming terms, is that they happen when they happen. So your Blinky code there, if we just look at it again, while it's running that delay, which basically says sit here and do nothing, doing nothing cannot be servicing an interrupt. So if an interrupt comes in, when that kind of code is running, which is we call blocking code, which is not good code to write and will absolutely prevent you from being able to properly and correctly run asynchronous code. If that happens, you miss that event, your application is broken and stops working and probably crashes. So timers, if we can have a timer function that will get round all this, it'll be a great start. Now the ESP comes with what's called a ticker library, which does exactly that. It provides an interface to the timer structures of the hardware, and it kind of does an interrupty timer thing, but it's not actually an interrupt. It's a lot easier to use. It gives you a nice simple interface, so it solves many problems. It hides the tricky interrupt handling and provides a simple interface. There we go. But it still has many limits. It also runs in a reduced context, like an interrupt, but it's not quite as obvious that that's the case. So it's very easy to put in there code that breaks those rules that's going to make that flimsy bridge collapse and your app crash. It's only got two types of timer. You can fire a single shot timer which says interrupt me, wake me up in X amount of time, and that's the end of it, or a repeat timer, basically wake me up every 5 seconds, 1 second, 150 milliseconds, whatever. The value can change, but you've got two functions, single shot and repeat. And the only function that it can call when that timer happens is what's called a bare static function. If you don't know what that means yet, don't worry. You've probably been writing them all of your C career. It's just a kind of ordinary function, nothing fancy. It can pass data to that function, but that's limited to a single 32-bit value. Now that's great for simple apps, but once you start getting into the likes of the type of thing that H4 plugins deal with, all of those rich kind of events, you need more than that. And also in modern programming style and technology called functional programming, what you really need is when that timer happens to be able to call any kind of function or functor in the C++ language that C++ can call. You just want to run it when the timer happens. So, if you look at the video in my rant series, video 3, Arduinos don't have Wi-Fi running, so they've only got one single task, so they're like the major highway, and you can write any code you want and it doesn't matter because there's nothing else to upset and it works. When you take that code and put it on an ESP8266, which has got Wi-Fi running in the background, that's another task. That does interrupts all the time, has to keep talking to the radio. So if your code blocks it, like with those delays and things, it objects, it complains to the processor restarts and crashes. More detail available there. The point is, not only do we're working on different hardware, we need some different software, and that is what H4 was written specifically to do. What H4 does, it takes all of these complicated and rich events and sticks them into a massive great big mincer which runs on the main loop and then spits out a single synchronous series of events. And what that means is that they happen at a time that is controllable. All right, so basically it takes this kind of ragged Wild West and smooths it out into a series of messages to your code saying, oh, this just happened, oh, that just happened, oh, the other just happened. But all of that code runs on the main loop, which means that all of the problems you get that we mentioned earlier about interrupts and ticker timers, out of the window. Your code can do anything that normal code can do. So you can run long tasks, asterisk. You can run complex tasks, asterisk. You've got no problems with data sharing because you're running on the main loop. The only problems you've got are the same problems you get with any normal code. You don't have to worry especially about synchronizing it between background contexts and all that complicated nightmare. Out the window. So you've got no problem with blocking Wi-Fi because H4 behind the scenes makes sure that it only calls the timer functions and your callback functions as they're known when it's safe to do so. So the other benefit it's got is that rather than just having like an every 5 seconds, it's got 11 different types of timers. So it can call a function that you write every random number of seconds between two values. It can call a function a specific number of times, very simply. It can call it a specific number of times between two random intervals. Just once, like a normal ticker. It can call it once at a random interval. Q function I'm going to come back to in a second. But it can call the function a random number of times, and it can call it a random number of times for different random intervals. It's got a very useful function called repeat while, which will do a big loop of things that would normally take a long time. And remember those asterisks? Even though you can do those without crashing, it's not a good idea to. You still can cause problems if you write bad, long, slow code in an H4 timer callback function. But repeat while allows you to kind of walk through that array, for example, once per loop cycle without even knowing you're doing that, and it feeds you the next part of the array each time. So you can repeat while that array has still got data in it. You can repeat a function. And you can do a repeat while ever, which will then reset the initial conditions and start again over and over and over. Now, talking about that Q function basically says it's not a timer at all. It says put this task in the queue now. So the function that you put in the queue, if that's in response to any kind of asynchronous event, then suddenly your asynchronous event becomes a synchronous event because it won't get pulled out of the queue until the next time around the main loop when the code is ready to deal with it. So queue function is the key thing that allows us to smooth out the asynchronous nastiness and make synchronous joy. And the other benefit of that is that the function that gets called by H4 can be a normal bare function, it can be a class function, a class method within a class. It can be any, what's known in C++ as any functional object. So anything in C++ that is a function, or can act like a function, or look like a function, or be called, can be the target of one of these 11 different timer types for H4. And that allows massive flexibility. So what we're going to do now is we are going to jump over to the real thing. So if you just come into the channel or just come into H4, here is your first H4 program. There's a couple of important things to spot. There's no setup, there's a thing called H4 setup, and there's no loop. The reason is because H4 controls the loop. It knows when things are happening. It does all the clever hard work in the background. You don't need to. And so you cannot have a loop function. All code which H4 runs is run as a result of it being a callback function from one of the timers that we've talked about before. All right, now it really doesn't take a rocket scientist to see what's going on here. I've got 3 LEDs on that device on D6 and 7. Do the standard stuff of, setting them as output. And then here's H4 working. We say we have an every timer. We have an every timer. And every 750 milliseconds, if you're not familiar with this syntax, don't worry about it. That just, it's the structural scaffolding behind calling a functor. It says every 750 milliseconds, call my callback with a parameter of D6. Every 500 milliseconds, call my callback with the parameter of D7, and every 250, call it with a parameter of D8. And you do that in setup. That's often running in the background. You've now got 3 tasks running in that queue that will regularly call the function that you named on the interval that you named, and it will do that until the power cuts. Do it forever and ever and ever. So let's look at my callback. It's very, very simple. Bear with me a second. Let's just turn the video capture off. All my callback does is toggle the pin. It just inverts the state of the pin. It does a digital read on it and sends the opposite value back to the pin. All right? Now, I think you can agree that that code is very, very simple, very straightforward, very clean. It's very, very easy to write. I personally think it's easy to understand once you kind of get over this kind of thing, which you will very rapidly. And all of the things that happen, interestingly, which is the bit that you put in here, all of the actual functionality is done in functions that you name. No setup, no loop. You fire off things from H4 in setup, and everything else just works. So let's put our little live show back on again for fun. So you can see the red one is flashing once every 750 seconds, the amber's every half second, and the green is every quarter second. And it will do that forever. So, what I'm going to do now is this. We're going to have a quick summary of what we've covered today, and then I'm going to start thinking about the next videos I write, getting into the much more advanced concepts. Okie dokes. Let me sorry about this, I'm having a bit of a nightmare getting myself back to where I want to be. So in theory the last time we were there, we just talked about all of those things. So, summary. We learnt some simple terminology. We learnt about a thing called context, and that there's two of them, main loop and not main loop. Things happen asynchronously, and we know that blocking code is bad, and we should never call delay because it stops us being able to run asynchronous code, and that's how code works. Certainly on an ESP8266 running Wi-Fi. We saw that there are problems with interrupts in that they're complex and error prone. We saw that there's problems with tickers, is that they're limited to two types and they can only call static functions. And we then saw that H4 solves the problem by putting all of the async events into a synchronous queue. It runs all of your code in the main loop concept. It's got 11 types of timer and it can call any C++ functor. I think my time here is done. I hope you enjoyed that. Thanks for watching. And come back soon for the next ones in the series where we look much more in detail at all the other 11 timers.